Okay, good, thank you. Okay, so if you guys can just pull out the handout that I gave you for chapter 10, which is table 10-2. So again, just to confirm, for chapter 10, we will just be covering this information, and this information only is what you'll be tested on for next week. So there is no PowerPoint that is given to you for this chapter other than this information. So table 10-2 covers the 4 different types of hypersensitivity disorders. This is important that we go over this because some of the examples or some of the conditions that fall under this category are a lot of different conditions that we're going to cover throughout the term, such as asthma, when patients go into anaphylaxis or anaphylactic shock, even if we talk about lupus. Okay, so there's different conditions that fall under these set of disorders. And so I just want to give you this background information so it can help us in the future. Now, with this table, I'm going to tell you right now, you're not going to have to memorize each and every item, so let me tell you exactly what you need to highlight. Okay? So if you go under characteristics, if you can highlight mediated by, highlight the section mediated by, highlight the section that says immune response, highlight peak action, causes of reaction, and manifestations examples. In the manifestations examples, this is very important because this is pretty much how your test questions will be. So you will have examples or an actual disorder and what category it falls under and things like that, okay, or the information behind it. So let's start with type 1. Type 1 is what we call atopic or anaphylactic. When you hear the term anaphylactic, what is the first thing that comes to your mind?
Anaphylactic shock.
Anaphylactic shock, and anything else? So keep in mind, when we have anaphylaxis, anaphylaxis is usually some sort of allergic response that the body is undergoing. When that person goes into anaphylaxis, which is the allergic response to that particular agent, whatever it may be, then if it goes on too far, then they lead into anaphylactic shock. Okay, so let's just go over anaphylaxis or anaphylactic. Okay, so the first thing here, it is mediated by immunoglobulin E, IgE. And I think you guys remember from physiology that IgE is an immunoglobulin that is definitely secreted when the body is in a situation of an allergic response, okay, during the allergic reaction. The next thing is the immune response. The immune response just pretty much kind of describes sort of the pathogenesis as to what's happening with this particular disorder. So AG stands for antigen, that's abbreviated for antigen, plus IgE leads to mast cell degranulation. Okay, so what does that mean? Just to put it in a nutshell, what happens is this. The person comes into contact with the allergen, whatever they inhale, let's just say, for example, if they're allergic to dust or cut grass or whatever it may be. Once they inhale that material, that particular antigen is pretty much synthesized in the immune system, where it will now start to kick out immunoglobulins. We'll have different immune cells that will be secreted. And then what will happen here is that mast cells, we know, will be secreted with that response. Once mast cells degranulate and break down, what is it that they release, if you remember from physiology? Mast cells release something.
Histamine?
Very good. They release histamine. And if you remember, histamine is definitely one of those things that is released during the allergic response. It's a chemical mediator where your body will now start to attract more white blood cells to the area to fight whatever it may be. So to also put this in a clinical perspective, histamine release actually gives us the itchy eyes, watery nose, scratchy throat, so all those signs and symptoms that we have from an allergic response. You guys know that we take an antihistamine over the counter to suppress the histamine, okay, to kind of suppress the symptoms. But just know that histamine is a normal response when we undergo the allergic reaction. Okay, so jumping down, peak action will be 15 to 30 minutes, which means that this person will come into contact, if they come into contact with that particular antigen or allergen, they will have signs and symptoms, or the inflammatory response will definitely come out within that time frame, 15 to 30 minutes. It's very fast acting. And if you jump down to causes of reaction can be T cell deficiency, abnormal mediator feedback, or environmental factors. Okay. So T cell deficiency, if for some reason, I'll come back to that. For some reason, if our T cells, okay, are not functioning properly, because remember, we do need that adaptive immunity to also help, okay, in this situation, so that could also cause this person to go into sort of an allergic reaction. Abnormal mediator feedback, so if the body does not, let's say, maintain homeostasis or take into, I'm trying to think of a good example, one of the students, yesterday's class, she said that sometimes with patients, wherever she works at, sometimes with patients when they have their blood drawn, that they will actually go into an anaphylaxis after. And so that is an example of abnormal mediator feedback, because what happens if you are taking something away from the body, obviously the body is supposed to, you know, maintain homeostasis and bring those levels back to where it needs to be. However, this can now lead into a sort of anaphylaxis situation if it doesn't bring it back to homeostasis. And then environmental factors, definitely anything obviously that's in the air as far as pollen, dust, any type of environmental things that a person could be allergic to. So very good examples we have are manifestations: asthma, rhinitis, atopic eczema, and bee sting reactions. Okay, and so those I'm quite sure we have heard of as being allergic reactions. Okay, now type 2, yes?
What is atopic eczema?
Atopic eczema is what we call the, how can I say, the allergic, or falls under the category as type 1 hypersensitivity. So sometimes when patients have eczema, or even when we cover asthma, sometimes they say that patients that have asthma will also have eczema. And the reason why is because their immune system falls under the category as a type 1 hypersensitivity. So let me explain. Hypersensitivity is kind of like saying the immune system is doing what it's supposed to do. However, it's like heightened to the 10th power when it comes into contact with that particular antigen, whatever it may be. So sometimes patients that have eczema, it is seasonal.
Yeah.
You know, it is sometimes environmental type things, because it falls into that category as type 1. So atopic is pretty much saying just like the allergic type form of eczema.
Okay. It's funny that you say that, because I do have asthma and I do have eczema.
Yeah, most of the time, well, I don't know the exact percentages, but they do say that most of the time the patients that do have asthma will also have eczema, because it just falls under that same category. Okay, so type 2, cytotoxic, also known as cytolytic. So when you see those terms, what does that mean to you? If you see cytotoxic, cytolytic. Very good. Damage to the cells, or definitely cell death. Okay, so this is cell death, and so something is going on here or occurring where these cells are dying. Okay, so let's go over this. It is mediated by IgG or IgM. For the immune response, we do have a surface antigen and antibody that leads to killer cytotoxic action, which means that as soon as the body comes into contact with another cell that it believes is foreign, it will immediately kill that cell. Okay, and so this is what we're talking about. The peak action here is 15 to 30 minutes, so this is also very fast acting. And if you jump down to causes of reaction, this can be from an exposure to an antigen, a foreign tissue, cell, or graft. So I'll kind of jump into some of the examples. Very good examples. This is when individuals have blood transfusions that the body actually refuses. Okay, and so what will happen when they do receive that blood, whether it's a match that's not supposed to be, or whatever the case may be, the cells in the body will immediately attack, okay, and kill those cells. Another good example, if people have certain types of tissue grafts done, or organ donations and organ implantation, where the body will attack that particular organ and tissue and kill it, okay, or attack it. Now, another good thing, or I should say another good example. You guys remember, I don't know if you went over this in maybe maybe anatomy or phys. There's a condition called erythroblastosis fetalis. Now, it's not that common because they usually take care of it as long as the mom has proper prenatal care. But this is when the mom is Rh negative and she can possibly build up antibodies against her own baby. So that's another good example. Okay, so if that's not taken care of in a timely fashion, the mom can build up antibodies and they will definitely attack the cells of the fetus. Okay.
It's after the first birth, right?
Yes, after the first birth, yes. Okay, so that's a good example, so that's type 2. Now, type 3 is what we call the immune complex, also known as adverse reaction. Sometimes I have a difficult time explaining this one because it almost sounds like the normal immune response that occurs. However, I will say this, your autoimmune diseases do fall under this category, okay, this one. Okay, so it is mediated by IgG. The immune response here is antigen-antibody complex, okay, in the tissues, where complement will activate, and PNN just stands for neutrophils, polymorphonucleic neutrophils. Those are more attracted, so it will attract more neutrophils to the site. So it's basically the same immune complex that happens with anything. However, the peak action here is a little later. It takes 6 hours for this reaction to occur. Okay, so it takes a little longer. Causes of reaction can be persistent infection, extrinsic environmental factors, so this can also be an allergic type of situation. So believe it or not, all allergic reactions are not just type 1. You can have some that do fall under type 3. And then also our autoimmune diseases fall under this category as well. And we all know autoimmune disease is when the body pretty much attacks a cell that is self and looks at it as a non-self cell, okay, and kill it. And so very good examples they have listed here: glomerulonephritis, SLE, also known as lupus, which I believe we'll go into later on in the term, farmer's lung arthritis, and vasculitis. Okay, these do all fall under that category. Now the very last one we have is delayed hypersensitivity, type 4. With this one, lymphocytes, T lymphocytes is mediated by T lymphocytes. The immune response here is antigen synthesized T cells that release lipokines, leading to inflammatory reactions. I do want you to highlight inflammatory reactions because what you're looking for here, you are looking for inflammation. We're looking to see signs of inflammation for this particular reaction. The peak action is 24 to 48 hours, or a day or two. Okay, this is why they call it delayed. And the causes of reaction: intradermal, epidermal, dermal. So what does that tell you? Everything that has to do with the dermis, okay? Which is where you're going to be looking or assessing to see that inflammation, the signs of inflammation in the dermis. Very good example, even though they have tons of them there, but a very good example that I'll use is what you guys will be doing pretty soon, or maybe have done already, is your TB test. So the TB test, as you know, is performed where they inject the tuberculin where? In the forearm, and they do put it right where? Right, like at the, right underneath, okay, the skin epithelial, right, that layer, okay, of the dermis. Now, when do you have to go back to have it read?
2 to 3 days.
2 days, okay, so this falls under the category as a delayed hypersensitivity, 24, 48 hours, maybe sometimes they tell you up to 72. What are they looking for when you go back to have it read? They're looking to see if it's raised, they're looking for redness, some sort of signs of inflammation, okay? If you have been exposed to TB, and with that particular test, that will tell us, okay, that that person is definitely undergoing that condition, okay, at that time. So, that's type 4. All right. So, does everyone understand all the hypersensitivities? Okay. So again, just hold this information, go over this for next week's test. I may have maybe 2 questions or so from this, okay? But again, just kind of focus on all the material as well as the examples, okay, the examples I gave you. Okay.
Yeah.
guys do not have this as a handout for you. This is just review, and I just want to review this. I didn't want to give it to you as a handout because I'm not going to test you on normal. I just want to do a quick review just to make sure we're all on the same page. Now, there's a couple of reasons why I want to review histology slides of blood cells. Number one, we are including today our clinical reference guide, and everyone gets really excited about lab values and going over CBC panels and things like that. However, sometimes students forget just the normal function of a white blood cell. Okay, so we can look at labs all day, but if you don't know what the cell normally is supposed to do, or what it secretes and when it's elevated in the body, what may be happening, then it won't make any sense. So we're going to go over the functions of these cells, and we also want to go over how to describe these cells. Okay. So if you remember in histology, you guys took a look at all the blood slides and figured out which was which, and understanding what's in the cytoplasm, what's in the nucleus, okay, how is it shaped, and things like that. This is so important because I need you guys to remember normal, because what we're going to spend probably the next 2 hours on is looking at all of these blood cells that are actually cancerous. So we need to figure out what normal looks like before we start looking at cancerous blood cells, okay? All right, so let's go through this. So the first cell, if you guys can describe to me, what is in the cytoplasm? Granulars, very good. This is granulated. And the color of the granulars are what?
Red.
Red. Very good. And how would you describe the nucleus?
Bilayer.
Yes, the nucleus is bilobe, and it is stained purple. Okay, so this particular cell, has red granulars in the cytoplasm, has a nice purple bilobe nucleus. This is the only circulating white blood cell that has this distinct look. What cell is this?
Eosinophil.
Very good. This is an eosinophil. And the eosinophil is granulated, so it falls into the category as a granular site. Now, what is the function of an eosinophil? I know I'm digging, but there's a reason, because we're looking at lab values today. We're going to be including a CBC with diff, and we're going to be looking at white blood cell differential. I'll have you guys highlight that, so we need to know what the functions of these white blood cells are.
Does it do with histamine? Does it release histamine?
Not histamine, not that one. That's another granular site. This one is secreted when, or I should say, it attacks a particular type of infection. And you need to know this in case you ever see a patient with elevated eosinophils. Parasites. Eosinophils will be elevated during parasitic infections. It will also be elevated when patients undergo some allergic reactions as well. And in particular, allergic type asthma. So when patients do have like acute asthma attacks that are the allergic form of asthma, they may have elevated eosinophil rates. So we can just say parasitic infections and asthma. Okay. So that's important to know. Okay, now, the next one we have here, I'll help you with the cytoplasm because I know it looks fuzzy, but the cytoplasm is granulated. Okay, so the cytoplasm is granulated with this one. The nucleus, how would you describe that nucleus? It's trilobe, yes, or also what they call multilobe. So this is the only white blood cell that has a multilobe nucleus with granulars in its cytoplasm. And I'll give you another hint. This is the most abundant white blood cell circulating in the bloodstream. Very good. This is a neutrophil. Okay, and we need tons of neutrophils. If you remember, neutrophils are almost like our first line of defense, and so they are secreted no matter what comes our way. Okay, they're usually the first ones to attack. Now, neutrophils are also highly phagocytic. okay, if you remember that term from physiology. They are highly phagocytic, which is why we need them in high numbers, okay, because they're able to help when it's time for infections and anything like that. Okay, very good. Now, this one here, I'll help you with this one too because it's fuzzy. The cytoplasm in this one is not granulated, it's actually clear, okay? And what's going on with that nucleus?
Swollen.
Not swollen, we don't want to use that term, but how is it shaped? Like a U shape, yes, this is a U-shaped nucleus. And what is it about this cell that looks different than maybe the other white blood cells? Kind of what you said. Not swollen, but it's larger. It's larger in size, okay? This is the largest of the white blood cells, okay? And so this particular cell, if you remember, is what?
Monocyte.
Very good, this is a monocyte. And monocytes fall under the category as an agranular site. You remember your histology. That's good. Okay, so monocytes turn into something else. When they get to the tissues, what do they turn into? Macrophages. Okay, monocytes, don't forget, turn into macrophages once they get to the tissues. Now, on a lab panel, you would see it listed as a monocyte. Okay, so you would never see a macrophage listed on the lab panel because a macrophage is just a term that is used for that same cell, but when it gets to the tissues to fight. Okay, so monocytes turn into macrophages, and another thing you should know about monocytes is that they are also highly phagocytic, just like neutrophils. So they do help attack when need be. Okay, very good. Now, this particular one, usually students have a hard time, I remember in anatomy, trying to figure out what this cell was because everything has the same color and it's kind of superimposed on each other. And so, this one is granulated, would you agree? Yes. The granulars are dark purple. Can't really see the nucleus is dark purple as well, so everything's just kind of superimposed. However, what cell do you think this is? Basophil. Yes, this is a basophil. And basophils help, they actually secrete two things. What do they secrete? I think you said it earlier.
Histamine.
Histamine, they definitely secrete histamine because we know basophils also convert to mast cells. And basophils, believe it or not, they also secrete heparin, okay, when needed. So they do secrete histamine and heparin. Okay. Now, the very last one here, I know we all know what it is by default. However, let's just still describe the cell. When you look at this cell, most of the nucleus takes up most of the cell. Okay, then you see very little cytoplasm, okay, surrounding it. This is agranulated, so there's no granulars in the cytoplasm. And we all know that this is a lymphocyte. Now, lymphocytes break down into three categories of cells. What are those three categories they break down into? T, B, and
Is it the natural killer cells?
yes, very good, natural killer cells. Okay, so lymphocytes break down into T, B, and natural killer cells. So it's important to know this because we know that lymphocytes is part of what we call our adaptive immunity, and so they do fight the immune system in a different way than what a neutrophil would do. So T cells, if you guys know, they do attack viral infected cells, so they're there to attack viruses. T cells attack viral infected cells. And believe it or not, T cells also attack cancer infected cells. And this is important to know. Keep in mind that the body will try to fight the cancer and it will try to kill the cancer cells as best as it can. Unfortunately, it's not at a fast rate as we would like it to be. But T cells will try to attack those cancer cells. B cells, I think we know they also are part of our immunity, where they do fight multiple types of infections, but they do this by the way of producing antibodies, and we know that they go to antibody route. And then natural killer cells, we know, just directly attack the kill. So, we're all good with that. Okay, so now you know, you look at a panel and you know if something's elevated, what could possibly be going on, okay, because we know now the normal function of these cells. Now, another thing too, the reason why I went into detail with describing these cells, we will be looking at, well, number one, this is the mature version of a normal cell. Okay, and the reason why I want to say that is because some leukemias, believe it or not, can attack the mature version of a cell, and sometimes it can attack the immature version. And so we need to understand the difference. So what's going to happen is, this is normal. Okay, so that's why I wanted to go over this, because now we're going to look at abnormal, okay, and it looks different, okay, totally different than this. When you look at a malignant cell, okay, like this. Okay, is everybody good with this? So. Started with chapter 11. Now, just to confirm, I think you guys have, I don't know, your chapter 11 PowerPoint, we're going up to slide 69, I believe, but your PowerPoint may have more information. It depends on which one I copied. If your PowerPoint goes all the way up to lymphomas, again, just to confirm, we are not going to cover lymphomas. There's only 2 lymphomas that is covered in that PowerPoint. We're going to save those 2 lymphomas for later, okay, for your topic list for later, for week 8. But we are going to cover all the leukemias, okay. So you guys, some of your PowerPoints just go right to 69. Some of you may go past that, okay, so I just want to clarify that. All right, so for chapter 11, we know from last week that cancer spreads through blood and lymphatic tissue, okay, that's the way it spreads, which is why they have an entire chapter on primary blood and lymphatic cancers. Okay, so we have a whole chapter on this. It is quite long and detailed, so we will go into this information. Now, chapter 11 covers malignancies of white blood cells. And so just to go over some of the nomenclature here. A leukemia, lymphoma, plasma cell myeloma, these are the 3 main things we're going to focus on. Well, really 2, because lymphomas we're not going to do. But leukemias, they say, are circulating tumors that are disseminated from the beginning of disease process involving blood and bone marrow. To make that more of a simple definition, leukemias are actually malignancies of white blood cells in blood and bone marrow. Leukemias are malignancies of white blood cells in blood and bone marrow. So it's called a leukemia because of its location. Okay, if that makes sense, in the blood and bone marrow. Now, when we talk about a lymphoma, okay, so just to give you the definition of this one, a lymphoma is a malignancy of a white blood cell in lymphatic tissue. This is a malignancy of white blood cell in lymphatic tissue. And plasma cell myeloma is a malignancy of B cells. Okay. Now, they put them in a whole category by itself, and the reason why, these are the antibody secreting B cells that are cancerous. They put this in a different category all by itself because it behaves totally different than the leukemias. It's actually, it's a chronic leukemia, but it can be very aggressive, and so they have a lot of different signs and symptoms. And so you'll see when we get to that section. Okay, now, categories. Keep in mind that when we talk about blood cells, okay, in the maturation process, I think we all remember from anatomy that there's one main stem cell, okay, that goes through a maturation process that gives rise to the mature cells, okay. Now, they do have two different lineages that these cells fall under, and I do want you to know this. Knowing the lineage actually will help you with the names, okay, of the cancers, because sometimes you do see these leukemias abbreviated, like CML, ALL, things like that. So, myeloid lineage is going to be any cells that are red blood cells, platelets, monocytes, and our granular sites, which we know our granular sites are all of these here, okay? So all of those cells fall under the myeloid lineage. The lymphoid lineage is anything that's a lymphoid cell. So a B, T, natural killer, okay? So to make life easier for you when you're studying, lymphocytes fall under the lymphoid lineage, everything else falls under the myeloid lineage. Okay? So what is the purpose of this? The purpose of this is when you guys look at, say for example, the abbreviation. So say for example, you see somewhere you're reading in a book or even on a test question, okay, if you see CML, okay, what does that mean? And if you forget, oh, I forgot what it means. I'm going to show you how you can break down each letter so you can figure out exactly what's going on, okay? So C is going to stand for if the disease, the leukemia, is either acute or chronic. Okay, so C stands for chronic. And at any point, I just want to let you know, if we have a chronic leukemia, that means that it's attacking the mature phase of the cell. So it's attacking the mature cell. Okay. M stands for myeloid. So this means that we'll have some sort of malignancy at one of the cells that fall under the myeloid lineage, okay, whichever one it may be. And then L just stands for the leukemia. Okay, so at least just looking at that, it gives you some type of information. Now, the next one we have ALL. So if we use ALL, A for acute, and just to let you know, anytime we have an acute leukemia, it is attacking a cell at its immature stage. Okay, it's attacking a cell that is immature and it has not completely developed as of yet. It is attacking a cell at its immature stage. And it's also, the L in the middle stands for lymphoid. Okay, so it could be any one of those. And the last letter here, leukemia. And I'm going to put here / lymphoma, and I'm going to tell you why in a second. It could be a leukemia or a lymphoma. Okay, so let me explain.